Good afternoon, everybody. Um, Welcome to this webinar on CSC services for the bio users. I am Lakshman Etukuri, one of the bioinformaticians working at CSC. This webinar is mainly targeted for the newcomers of the customers who wants to use the CSC services. This webinar may be overwhelming for biologists due to the IT jargon or some of the commands that I will be typing on in the command line, but we have a good documentation of CSC services put together by CSC experts. So stay tuned. And there is also a chat box here. We will be collecting the frequent some questions. So if you have any questions, so please post there. We will either answer now or we will forward it to the experts in this specific service, and we'll get back to you with that. First things first. I would like to start off with to get started at CSC services, followed by some important CSC services that will greatly benefit your computational projects, namely CSC supercomputing environment, which is mainly about our Pukti supercomputer. And then I will be discussing about data storage environment, which is more about our new ALAS. And then I will briefly discuss about our CSC cloud services, which are some flavor of the Pauta cloud service. And then I will briefly go over some of the useful resources for the bio users. And finally, I will leave you with some take-home message. So accessing the CSC services, how to get started. Probably your the institution or the university or any other educational institute that you are working in has been part of the one of these identity federations, namely ACAR with you. So that particular user ID of that institute is your ACA ID. Using that, you can go to our customer service portal, which is at mycsc.fi. Then you can, if you are new, you can register as a CSC user, and then you get the user account. For some reason, if you don't have any of the credentials, either Haka or Virtue, you can, for example, you may be part of some Finnish projects, but you don't have any affiliations yet in any of the Finnish institutions, then you can always contact our customer service. Our customer service is service tech at the rate of csc.fi, and we are open on all weekdays from 8:30 to 4. In addition to getting a CSC account at mycsc.fi, you can also maintain your CSC project at this portal. You can open your account, obviously. You can apply for the resources. You can also edit or modify your personal information. You can add services, and you can also create the new projects here. So I will briefly go to this web page at mycsc.fi. So this will show an customer interface, something like this. So you can click on get started here. So as you can see, you have the VTU option and ARC option. If you click in VTU, so you may find one of these institutes as your host institution now. If you don't find, and you can check in the you can also check in Hakka. So you can find a lot of institutions that are part of the Hakka Federation. So you can choose one of these options, and then you can create an account. So for now, I can use my CSC credentials and then go to, I think it's stuck here. So my username. So you can end up seeing something like this. So the one that you show is the default project for you. And of course, you can go to all the projects that you are affiliated to. Within each project, you can see the information about that project, the project specific information here, and also the members of the project. In this project, I'm currently only the one here. You can, if you are a project member, there would be some kind of plus button here. So you can also invite members to your project. If you're a project manager, you can also add these services to this project. And also you can see that resource utilization of the current project. And also you can also apply for the additional resources if you have an access to here. So in this current project, I'm the only one, so not much resources, but we can, in other projects, because there are multiple people involved, I don't probably want to show it here. And also another thing you can do is you can modify your default project here. And of course, you can always change some of the things like fields information and so on and so forth. You can also change the password here. So it is very easy to use dashboard for managing your CSC accounts as well as your projects here. That brief too, I would go back to my presentation here. So then once you have a CSC account and you have access to the services like Puhti supercomputing environment or any other services, so you can start using that service. So now I'm going to talk about the supercomputing environment at CSC. In the first place, the reasons for coming to supercomputing environment could be that your local PC or laptop is not able to meet the computational demands of your project. Then the reasons could be like you need a huge number of computational memory requirement, or your laptop is less scalable. If you have an on-prem cluster, it may be that your cluster may not scale well to your computational project, and parallel computing is needed, but you can't do that in your laptop. It may be that you are bound by time, so you want to do the computations in a short time. Of course, there will be always installing programming that kind of programs to run your software. So then you may not be able to optimize the programs in a local computer. So whatever could be the reason, so you can choose some options. And supercomputing environment, the Puhti is our the only available supercomputer at the moment, as you all know. So this is a new supercomputer which is successor of the Taito, if you have already used that one. So this 50 computer also has some AI partition. If you want to accelerate some kind of machine learning or artificial intelligence algorithm, so this is also, you can also use that. So at the moment, unfortunately, we have 50 is overloaded because the other supercomputer Mahdi is going to be available soon. So all the customers are just using Puhti at this point. And you probably know, so there is going to be a new supercomputer late this year or early come next year. So that is the even bigger supercomputer. That's a European level joint venture, this Lumi, which is mostly empowered by the lot of GPUs. So for your high memory intensive jobs and parallel computing, this is going to be a very good resource for you. Some basic information about the Puhti supercomputer. The one of the advantages is that this supercomputer is available with already pre-installed lot of software applications. If you want to have a very quick look at those software, so we have a good documentation page here, so you can see those applications in the alphabetical order or even by the discipline. So you can see all those software stack that is available and also with very good documentation here. Yeah. And also, it's if you are very new to Puhti supercomputing environment, it's a good idea to have some basic idea of your workspace. There will be 3 directories that you probably would like to pay attention to. There's a home directory, Pro Apple directory, and Scratch directory. Home directory is more like your personal use. And you can only store small amount of data. The Pro Apple directory is more like common for the project, and you can keep small installation stuff, and then maybe you want to share code with the project members. And there is a Scratch directory, which is actually the place where you want to save the real data, and you want to keep the data there and start doing computational work there. And that is also a temporary space, and then there will be a automatic cleaning process. I think the files older than 90 days will be removed, or it will be implemented soon. So if you are using a lot of space, and of course it costs 1 billion units there. All the modules applications are supported by the module system in Puhti. So you can load any module with the module, any command, and the package name or the module name. There is, of course, you have to run the batch jobs on Puhti in order to submit your jobs into the supercomputing cluster. One of the modifications to earlier title is that there is an obligatory flag that you have to mention in your bash script, and that is you have to mention the project that you are using in that particular computational task. This is where we keep counts on how much resources have been utilized for your project. And recently we have also a support for interactive jobs. So we don't want you to run your heavy jobs on the login node. Instead, we'd recommend you to launch one of the interactive nodes and try to test your codes if you're testing and before submitting the jobs to the cluster environment. Nowadays, containers are everywhere. We do support Singularity container and HPC systems. Singularity containers are HPC compliant Docker-like environment, so you can use them. I would now try to go to the Bhukti shell and try to demonstrate a few of the things that I spoke now. So here, now I'm going to SSH to Bhukti. We don't need any authentication keys here. So now I'm inside the Bhukti login node. Now you can, for example, check CSC workspaces. So as you can see that we have mainly three workspaces. So it's my home directory, and then you have this project Apple directory where you can store the project directory, and then there is a Scratch directory where you can store actual data. And also I would like you to pay attention to the default quotas. My home has only 10 GB, whereas the Pro Apple can have like 50 GB unless you apply for more. And then the Scratch directory has 1 TB of file. And I will also like you to pay attention to the number of files in each directory. So there is a limit on number of files that you can keep in each directory also. So once you kind of get an idea about different workspaces, probably you would like to know how I can use the different softwares that were already pre-installed in Bhukti computer. As I mentioned, you can use module command. If you type the module spider, yeah. So it will show basically all available software, applications that are installed in here. So, and for example, and then you can pick one of those. For example, I can pick this one, Genome Analysis Toolkit. So I can load that one, that particular analysis pipeline. I have already activated that. If you want, you can also check if that is loaded there. So you can also use module list to see if you have loaded that particular package successfully, as you can see. So you have, there are the default compilers and the softwares that you can load. So this is how you would check if there is a software that is available for your scientific computing, and if not available, you can always contact us if that particular software is going to be used by many users. So obviously we may install it for you. So once you know your project workspace and then your programs you want to use, now you might want to of course you save your data in Scratch directory. So for example, this is one of my Scratch directory. I am going to so currently I am in my Scratch directory inside one of these projects. So So one of the things that you have to learn when it comes to supercomputing is batch scripting, which is a way to write certain flags inside the your batch script to request for certain types of the resources, and based on which your job will be queued there. So I can show, for example, some examples from our documentation. So it's here. Interactive jobs, for example, batch script. So if you can see that, so a typical batch script would start something like this, the batch option, and then you have to mention certain flags with starting with hash batch, where you can tell a job name, and then in this case also you have to obligatorily mention this account, the project information that you are going to use. There we have supercomputer was divided into different partitions, like depending on the type of the job. So you can write the time you are requesting, and then task, how many tasks you're going to use in your job, and then memory information. So this is how a typical batch job would look like. And once you write your job script, something, a real world application may look like something like this. I will show one example. So as I mentioned, so you have to write flags related to the bash script here, and also then you load the packages that you would like to use in your workflow. So in my case, I had to load different workflows here. Different modules here, and then you kind of write as a general script here, so that when you submit your batch job, so you just submit with this batch command, and then that will be submitted to the master, and then your job remains in the queue. So you can check the fate of your job. So something like this. So you can see that in my array job, one of the jobs is being run here. So other is in the pending. So while that job is running, you can also see the once the job is completed, you can also check the information about that job. For example, using the sef command, and then you can write that job ID, and that will show like the information about that job. There are some warning signs here. Just ignore it. And then you can see that the user group I belongs to, whether that job run has been finished, how many cores of the resources have been used, and also the efficiency of usage of the CPUs and the memory usage, and so on and so forth. This is where you can go back to your script and change the parameters here. So for example, I have used reserved a lot of memory, but I have used only small amount of memory here. So that's how you can build your bash scripts, and then optimize for your needs before you actually do real world computational tasks. So that is briefly about running a simple batch jobs on a Bhuti environment. I said that we also support Singularity. So you can actually, there are many ways to do Singularity work. And the Singularity, so for that you have to actually get the Singularity image and build from your own computer or somewhere, or you can also pull it from the Docker hubs using a Singularity hub if you can get the Singularity image from that. But anyhow, in this particular small toy example, I have my Singularity image here. This is a deep variant particular pipeline called a deep variant. So once we have the image here, the typical script for running the Singularity image could be something like this. Again, you will have your bash script related flags in the top, and then you can use the Singularity commands in the bottom of the script. Basically, this is the Singularity is installed in the compute nodes, so you can. This is the Singularity syntax for running the Singularity job. So basically, you bind this workspace here, and then this is the actual command that you would type otherwise. So you can just submit like before. And this application and this job will be executed when you find time proper resources. For example, I just use the small test example here. So this job is already submitted to the cluster and is being run here. So I just wanted to give by these examples a little flavor of how to use Bhukti environment for your usage, and it may be that in your real applications you may have a little bit trouble in running your jobs successfully. Then of course you can always contact our help desk if you are in doubt, or if you want to clarify more things, or if you want to optimize your computational jobs. That's about the little demo of the basic usage of the Bhukti. I would so you might be wondering, once you have the data and you have done some computational work in Bhukti, so then you're probably wondering, where can I keep that data? So that's where our new data storage environment, Alas, may come in handy for you. So this Alas is an object storage based service. So you can, meaning that the object data is stored as an objects inside the buckets, which is much analogous to S3 objects in AWS or Google buckets. It is actually meant for inactive data, meaning that you can keep the data as long as your project is active and not as a permanent place for you. So you have to think about proper exit plan when the project is going to finish. This Alas utilization, like in Bhukti service, it is a project based, so you don't have any personal place there. So all the project members of the project can use that common space here. So when many people are using the same project, so you have to pay attention to use of the data, because you may override or accidentally delete some of the objects there. So just pay attention to that. And the data in the Atlas can be, of course, accessed internally inside the either in Bukti or in the cloud environment and in the CSC, and also to the outside. You can share the data in any way you want. So then in practice, I would just like to demonstrate how to kind of put, once you have the data in Bukti, how you want to put it in Atlas, or if you get it from the Atlas. And also I would like to just mention that you can also download the data from your local space, for example, using our CPOT OpenStack Horizon interface, like mentioned here. And of course, you can always install certain APIs like Swift or S3 command line interfaces. And you can, if you are on the Mac or Windows, you can always install some graphical user interfaces that support these protocols. For example, CyberDuck. So we have very good documentation about these. So I would recommend you to look into those if you want to use it from outside. So the first steps for Bukti, obviously you should have an access to Atlas. Then that is probably obvious. So you have to go and accept inside your resources under in mycsc.fee, because that's not automatically granted to you. In Bukti, how do you set up your environment for interacting with the Atlas? So the Atlas is available as a module, so you can load it as a module, and then you configure Atlas setting using Atlas config command. And of course, there is a lot of documentation about using Atlas with our clone or AI tools there in our documentation. So one of the things our CSC experts did was simplifying these command line interfaces. We have something called AI tools, so they are a bit easier and safer to use. These are available right now inside the Bukti, so I can install these tools. You can also install in your local machines. The safer way comes from the fact that if you, for example, if you are using rclone or and Swift, such protocols, you may accidentally overwrite some of the objects in your bucket. So this we recommend using a tools if you don't know how to use properly other tools. So under the hoods, these A tools does is that it does automatic packing and compression, and then uses some of file hierarchical information on the file path when it creates an object in the Bukti Atlas environment. So this would just an example here. So for example, if you are in Bukti environment, and then say you have a project 1, 2, 3, you have a folder. Under that you have a folder case 1, which this files data 1, data 2, and so forth. Once you write output on case 1, this is like a command that you would give. This output is one of the commands in the AI tools to upload your data to Atlas environment. So with output in case 1 in Atlas, you are going to store an object called case1 tar. This is zip file under the this kind of file structure information as a bucket name inside the Atlas. So I would like to briefly demonstrate that in Pufti environment. So I am right now in Pufti supercomputer. I can actually go to Alas. So I have to now set up Alas environment before I transferring the data. So you can load module load Alas, and that is, and now I had to mention which projects I belong to, because Alas wouldn't know otherwise. So now it asks me what are the projects I should using. So now my connection is set up. So I could use simply put some directory, then it is going to ask me this project. And so now you can see that simply typing put and directory name, my files are now in the Alas. You can also give a bucket name if you don't want to have this kind of file name in your bucket. So you can write, for example, RNA-seq. So that will upload the same data, but in a different bucket called RNA-seq demo. So you can also check now. So other commands could be, once you have, so you can use other. So I wrote some commands. So you can also use some list to see what are the buckets that you have already stored there. So you can see that I have many other buckets in this project, including the one that I uploaded just now with the RNA-seq demo. So so if I can also see more information here. So if I type info and then the object name, so you can see that so you can see the metadata information about this particular object that I have put in the Alas. So where the original it comes from, what is the protocol used, what kind of compression was done, and what are the files that was uploaded to there. So, and similarly, you can also use, if you want to get that information, if you want to get that object from Alas to current environment, you can also use this one. I will just make a temporary directory just to show the, sorry. So now get an object name and then a get, that will get your object to here. So now you can see that your RNA-seq directory is here. You can check the files here. So those are the two files I uploaded to Alas environment, and I have retrieved those files from Alas to my environment. So you can basically quite easily navigate transferring data between our Putty computing environment Alas easily using these A tools. Okay. Okay, now I will go to other services called cloud services. So we have auto services. Usually the the cloud computing is useful, especially you think that PuFTY environment is not suitable for many reasons. You may, obviously you don't have a root access in our PuFTY supercomputing environment. So if you need a root access, or if you want to deploy your tools with web interfaces, or if you want to, obviously you cannot use the sensitive data in PuFTY environment. And of course, sometimes you have to wait in queue, especially if there are fewer resources available. And you think that you can manage even well than what's available there. So of course, obviously you can use cloud computing environment. Sometimes there may be complex scientific workflows that you think that you can better optimize and run it in cloud environment, then of course you can use it. So whatever may be the reason, so you can use our cloud computing services. You can think of CSC provides three types of the cloud service models. One is this infrastructure as a service model, and other is platform as a service model, and third one is the software as a service model. So the cloud providers, when provisioning these kind of services, cloud providers have to manage a lot of workload of managing the all the way from bare metal environment, and then the virtualization and operating systems, and all the application deployment. And so they instead can bypass some of their workload to the end users as well. So if you want to do everything by yourself, just they can provide some bare metal environment. So that's more like a self-service model. That is infrastructure as a service model. And in the platform as a service model, you can just deploy your applications, and the rest is taken care by the CSC. In a software as a service model, the service software is already deployed. You can start using that. So to oversimplify these models, it is having a virtual machine is like in the infrastructure as service, it's like owning your car. So you have to manage all your all the way from gasoline and repairs and the costas and all kinds of stuff by yourself. In IaaS model, in PaaS model is more like renting a car and then using it, and then the software as service is more like taking a taxi. So it depends. If you can manage service, you can start from the infrastructure as a service model. So this as if you are especially a biologist, so it requires some it has some learning curve in order to use this POTA environment. First you have to for example, if it is on CPOTA, you have to start creating a virtual machine. And on our we have so we have a CPOTA, for example, origin interface. I have opened it here. So in this interface, you obviously you have an access to, you should have an access to your CPOTA services. Then you can create your virtual machine here. I can, for example, I have created one virtual machine here. So once you have created virtual machine successfully, you can start using that. The use of creating a virtual machine and trying to use it could be a bit challenging, but at the moment, in the interest of time, I am assuming that you have a virtual machine environment here, and then I would like to just show you to how probably you can use it. So I'm typing this command. So I need to set up some keys. So and then your username, and then I'm logging into this virtual machine. So once you log into, so you can see that I'm inside one virtual machine. So I would like to demonstrate one use case here. So if you have managed to use create one virtual machine, and then you happen to own one VM. So here you can do anything. You can install your softwares you like. Actually, in fact, you can have your own operating system. You can run your any commands on this virtual machine because you have a root access to it. For example, I would like to use some Docker. So I would like to show how easily you can install, for example, our. So I can just go into Docker Hub to see how RStudio can be installed here. So you can find information like overview. So how to use the RStudio in the container environment. We can also see Docker file information about that RStudio image. And obviously you can pull it if you want to copy it from here, you can just copy it from here. So I will just take this command here, and I'm going to write in my virtual machine. So in this virtual machine, I have the basic root access. So I need root access to some of the Docker containers, so I can run it. I want to run in the background mode, so I want to and then here you have to publish your port here. So you can see that this is like Docker containers are exposed in this port, and they are in the different networks. So I have to map that to my host port here. And then you can actually send some environmental variable like password. So I just put like demo here, and then you can use your Docker image name available as in the Docker Hub. So if I can also write the latest image, something like this. But so once you type it, so you can see that this 800 port is already allocated. So I can maybe check. So I will just check that port was taken. So just so, so now I can see that the application that I am exposing at node 8000 should be available on the internet. If I just type the 1.0. So you can see that I was able to get RStudio up in a matter of few minutes just by using using the containerized application. So I just wanted to show this example. So because you can do lots of things if you own your virtual machine, it's more like your playground. You can write whatever complex software workflows that you want to execute in your computational project. So that's about a brief demo. So other useful cloud service that CSC has is the sensitive data management. So we have ePauta service. This environment is actually designed mainly for sensitive data. And you have to use it as a self-service model. So you basically have to be in a separate network, and then you have to manage all the virtual machines and all the related software deployment by yourself. So I have to mention here, so there are many related developments going on by our Elixir community here. So Elixir, probably you know that Elixir is a European level framework that was designed to improve the bioinformatics infrastructure at the European level. So it has, even in the Finland, we have this core communities, and also it's been also managing a lot of core data services that you probably are already aware of. So if you are interested in knowing more about the Elixir activities, you can contact us. So I would like to briefly mention about other relevant services as well. So one of the services is like you can ready to use this notebook services that CSC has been offering. You don't have to do anything like software installations or setting firewall works. You can just log in with Akai account, and you can readily start to use using Jupyter notebooks, RStudio. We also have more the modern notebooks like Apache Spark, and you can use the TensorFlow and the Keras environment for your deep learning applications. So this is, for example, quite useful if you're a teacher and then you want to run your course. You can just quickly get the same environment for all the participants of the course. So one of the most used BIOS software from CSC is Chipsters. It is graphical user interface based, so it's very handy for example, for biologists. So it has a lot of tools. You can do different types of analysis like single cell RNA-seq or RNA-seq, microRNA sequencing analysis, and so on and so forth. It also comes with excellent tutorials, so you can easily follow it, and then you can access using your Hawkeye account at CSC, or you can also I think you can install it on your desktop as well. I had to. Some of you may be aware of already our training programs. We offer a lot of trainings every now and then. So all the way from programming to computing platforms, HPC, and software data and networking and IT security. And also you can find by field specific courses like Spring School courses. and chemistry, and also we have a BioWeek course for bioinformatics related um, topics. And I had to also mention that there are always, you can also watch these webinars in YouTube later, and we will be available as part of the training archives there. And we are also supporting the e-learning now. We are probably in the beginning phase, but there are already some material out there if you want to explore. Especially for bio users, you can also see a lot of useful information about the different bioinformatics topics in our in the research.csc.fi webpage. And obviously, as I mentioned before, a lot of chipster material, both videos and as well as the material is available for you. So, for example, and I have to mention that there we have the recent course on RNA-seq tutorial. It is very it was written in a way that it's self-explanatory, and then you can use our virtual machines and then the command line environment that we wrote the documentation about there. So it might be interesting, and you may want to go and check the pages. And another service is FAIR data. CSC is supporting the FAIR data principles, and obviously aim is to provide a service for storing and describing, sharing, and preserving of the research data. So this is provided by the Ministry of Education and produced by the CSC and the National Library of Finland. So you probably heard about the EDA data storage. As mentioned, ALAS is only for active data storage, meaning that you can only use it during the lifetime of the project. But if you have a fine data set and you have an intention to publish them, you can use our EDA service, and it will get one DOI number. You can find it using the HSIM, so that way it is reusable, and then you can also add metadata. Eventually, if you have a data that needs a long-term storage, like several decades, you can also use our paid data pass service here. Finally, the take-home message. So if you are a customer already, you probably know that you can manage your account at mycsc.fi, and if not, just create an account using mycsc.fi. So the idea is that I have only touched fewer services that CSC can offer, but in reality, you can think like starting your project all the way from the planning through data collection and computational task and the data storage and finally publishing. So there may be some tools that we are able to help you in a different phases of your life cycle of your project. I like to mention that these resources are free for an academic use, and as long as you do this open science research. And obviously, the CSC resources are much different from your laptop environment or a single workstation you may have it. I would like you to encourage you to participate in the CSC training and go through our raw materials and watch our webinars to get a good overview of your field of interest. And always we have a good documentation on how to use our services in CSC in the docs.csc.fi. And for bioinformatics related thing, you can join us and the bio newsletter. So we will keep you posted with the latest development at CSC for every once in 2 months or 3 months. And of course, for any type of queries, you can always contact us at servicedesk@csc.fi. So with that, I would like to end my webinar here. And if you have any questions, please ask now. We can answer it now, or we can get back to you later. It seems we don't have any questions, and thank you for your interest.